Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain calculus application with the focus on maximum or minimum profit problems. This is lesson 3 of 5. Have you subscribed yet? You can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. Example 1. A certain factory starts to produce Winnie the Pooh bears. The profit of the factory in rands per week W is dependent on the number of workers X according to the formula W equals minus X cubed plus 108X. Question 1. Determine the number of workers that must be employed to ensure maximum profit per week. Again, maximum minimum derivative equals 0. So we will take the profit equation and we will say dw over dx and we find the derivative equals minus 3x squared plus 108 equals 0. Let's solve x. Let the 108 walk across and we will divide away the negative 3. So we end with x squared is 36. Therefore, x is plus or minus 6. And then obviously x will be 6. Number 2. Now what is the maximum profit per week? Remember, I taught you that every x has an original y value. So what we're going to do now is into the original equation, the profit equation, we will substitute 6. Therefore, the profit will be 432 Rand. Example 2. The sum of two positive numbers is 12. Number 1. If one number is x, determine the other number in terms of x. So when we have the sum, it means plus of two numbers, so it's x plus y equals 12. So they tell us that one number has to be x, so therefore x plus y is 12. Now the question says determine the other number in terms of x. That means we will make y the subject of the formula and there must be an x in the answer. So therefore this other number is y is equal to 12 minus x. Question 2. Hence, determine the two numbers such that the sum of their individual squares is a minimum. So again, minimum, maximum, differentiate, equate to 0. But we need something to differentiate, so we need an equation. Now, do you agree? The sum, there's the plus, of the individual squares. Squares means to the power of 2. So the one number was x squared, their sum, and the other number was 12 minus x squared. And there's your equation. Let's multiply it out because we want to find the derivative. And remember, we can't find the derivative if there's brackets. So therefore, the 12 minus x, you will write it twice and you can multiply it out. And you end with 144 minus 24x plus x squared. And then you can add your two like terms. X squared plus x squared is 2x squared minus 24x plus 144. So now there's your equation. To find the minimum, we will find the derivative equals 0. Therefore, it becomes 4x minus 24 is equal to 0. Let's solve x. 4x is 24. Therefore, x is equal to 6. So the two numbers are, the one is x is equal to 6. The other number was y is 12 minus x. So in x's place, we substitute 6. Y is equal to 6. So therefore, the two numbers are 6 and 6. There are 40 fruit trees in an orchard. The average yield per tree in a season is 580 fruit. The farmer calculates that for each additional tree planted in the orchard, the yield per tree will drop by 10 fruit. If the number of additional trees planted in the orchard is X and the total yield of the orchard in a season is N, then N equals 40 plus X in a bracket times 580 minus 10X. Calculate how many additional trees must be planted to maximize the total yield of the orchard. Now again, we want to maximize, therefore we will take the given equation, find the derivative and equate to 0. There's our equation, and the problem here is we cannot find the derivative if there's brackets. So first of all we need to multiply out the brackets, and we end with 23,200 plus 180x minus 10x squared. Now we will find the derivative, and can you see the notation that I used here, n-x. And then the derivative equals 180 minus 20x. And since we are maximizing, we will equate the derivative to 0. In the next step, now I will solve x, so the 20x will walk across, divide away the 20, therefore the answer x is equal to 9 trees. Example 4. In the diagram below, PXY is a point on the line segment RS with the equation x plus 2y is equal to 18, where x is in between 0 and 18. Q is a point on the x-axis such that triangle POQ forms a right-angled triangle. PQ is perpendicular to OS. Number 1. Write the y-coordinate of P in terms of x. So what was given was the equation of the line. X plus 2y is equal to 18. So what we will do is we will make y the subject of the formula and make sure there's an x in the answer. So therefore 2y is equal to 18 minus x, and we will divide both sides by 2, or rather both terms by 2. Therefore, y is equal to 9 minus x over 2. Then it's important to understand that OQ's length is x, and then that answer that you got there means it's the y-coordinate there at P. Therefore, the length of PQ is 9 minus x over 2. Now the next question says, calculate the coordinates of P such that the area of triangle OPQ is at its maximum. Again, maximum minimum, derivative equals 0. And we need an equation. And we will find the equation of the area of the triangle. So the area of a triangle is half times base times perpendicular height. Therefore, it's half times OQ times PQ. Half times OQ is x and PQ is the 9 minus x over 2. And then you can multiply in the half x into the brackets, and you end with area of the triangle is 9x over 2 minus x squared over 4. Then we want to find the maximum. Therefore, d area over dx, and it becomes 9 over 2 minus x over 2 is equal to 0. Let's solve x. The x over 2 will walk across, and then let's multiply away the 2, both sides. Therefore, x is equal to 9. But they want the coordinates, so now we know x is 9. So for the y coordinate, y was 9 minus x over 2. So in x's place we substitute 9 and then y is 4.5. Therefore P's coordinate is the point 9 and 4.5. Now you know everything on calculus maximum minimum profit. Click on the video in the right hand corner to take you straight to the next lesson. That will be calculus application rate of change.